Hi everyone, I am Devi Salakji from CAC Department, Rohini College of Engineering and Technology. Here we are going to discuss about the subject Computer Architecture and Organization. In this Unit 5 we are going to discuss. So today we are going to learn about DMA operation, that is direct memory access operation. So direct memory access control data transfer is used for long data transfer. For example, to read bulk amount of data from disk to main memory. To read block of data from the disk process, send a series of commands to the disk controller device telling it to search and read the desired block of data from the disk. When the disk controller is ready to transfer first byte of data from the disk, it sends DMA request DRQ signal to the DMA controller. Then DMA controller sends the hold request signal to processor hold input. The processor responds this hold signal by floating it buses and sending out a hold acknowledgement signal HLDA to the DMA controller. When the DMA controller receives the HLDA signal, it takes the control system bus. When the DMA controller gets controls of the buses, it sends the memory address where the first byte of data from the disk is to be written. It also sends a DMA acknowledgement that signal to the disk controller device telling it to get ready to output the byte. Finally, it asserts both the input output read and memory write signals on the control bus. Asserting the input output read signal enables the disk controller to output the byte of data from the disk on the bus, and asserting the memory write signal enables the addressed memory to accept data from the data bus. Thus, the input of the CPU is involved only at the beginning and the end of the register. After completion of data transfer, the whole signal is asserted to give control of all buses back to the processor. So this is the diagram for the interaction of CPU and the DMA. So this is the complete block diagram of a DMA block diagram. So first thing is we are having the DMA data counter as well as the data register, address register, control logic as well as IO devices. Next one is the processor we are having. So in this we are having three types of buses. First one is the data bus, address bus, control bus. So from the buses only the details will be transferred as well as the details will be taken for each and every modules. So in this we are having the DMA request, DMA acknowledgement as well as hold acknowledgement, hold data, everything will be transferred with the help of all the signals. So this one is the main diagram of the DMA block diagram. Data transfer modes. In this we are having three data transfer mode. First one is the single transfer mode, block transfer mode, demand or burst transfer mode. So first one is the single transfer mode. In this mode, device can make only one transfer, that is a byte or word. After each transfer, DMAC gives the control of all buses to the processor. Due to this, processor can have access to the buses on a regular basis. The operation of a DMA in a single transfer mode is given below. IO device asserts DRQ line when it is ready to transfer data. DMAC asserts HLDA line to the request use of the buses from the processor. The processor asserts HLDA granting the control of buses to the DMAC. The DMAC assert acknowledgement to the requesting IO device and executes DMA bus cycle, resulting data transfer. IO device asserts its DRQ after data transfer of 1 byte or word. DMA asserts DMA acknowledgement line. Next one is the block transfer mode. So in this transfer mode, device can make number of transfers as programmed in the word count register. After each transfer, word count is incremented by 1 and the address is decremented or incremented by 1. The DMA transfer is continued until the word count rolls over from 0 to WFH, and terminal count or an external end of process is counted. Block of transfer is used when the DMAC needs to transfer a block of data. So this one is the explanation about the 3 data transfer modes of DMA. So in this, it showed how the data will be transferred in 3 modes. Thank you.